look at this geometric progression. This progression is getting smaller and smaller. The common ratio here is 0.5. 5 over 10 is 0.5. Now, if we want to find the sum of all the terms, since this progression goes on forever, so the sum here is infinity forever. Now, if the sum goes on forever, is this sum to infinity will also goes on forever, keep on increasing? Let's look at this diagram. The first column is the first term. It is 10 units. The second column is the sum of the first term and the second term. So it is S2. It is 15 units. The third column is the sum from the first term to the third term. That is S3. It is 17.5. The fourth column is S4. It is 18.75. The fifth column is S5. It is 19.375. We can see that the curve is getting flatter. If this goes on forever, is the curve going to get flat finally? Is there a limit to the sum of all the terms to infinity? So, is there a limit to the sum of all the terms of this progression to infinity? Yes, actually. No matter how many terms you add up, the maximum value of this progression is 20. Now let's look at this equation. We are using this equation because the common ratio here is less than 1. It is 0.5. Now, as this value of n increases, this whole thing will get smaller and smaller. For example, if we have 0.5, 0.5 is the common ratio, 0.5 to the power of 8,000. The value of 0.5 to the power of 8,000 is very, very, very small, very close to 0. So as the value of n approaches infinity, this whole thing, r to the power of n, will become very, very close to 0. So 1 minus 0 is 1. 1 times a, we get a. So when the number of terms here, the n becomes infinity, the sum is given by this. Find the sum to infinity of the geometric progression 10, 5, 2.5, and so on. A is 10. R is 5 over 10, which is 0.5. Since the common ratio R is between -1 and 1, we can find the sum to infinity of this geometric progression. And the equation is this. A is 10. We plug in the number. R is 0.5. We plug in the number. and we get 20. When we add up all the terms of this progression to infinity, we will get 20. The first term of a geometric progression is 15, and its sum to infinity is 12.5. Find the common ratio of the progression. We are given the first term, a, which is 15. The sum to infinity is 12.5. And we want to find r, the common ratio. For this question, we call up this equation. A is 15. We substitute in this number. Sum to infinity is 12.5. We substitute in this number. And we need to solve this equation to find r, the common ratio. 1 minus r equal 15 over 12.5 equal 1.2. And r is negative 0.2. The common ratio of the progression is negative 0.2.